So a quick talk through of what we've got now with the latest LTO 48 cell attempt to try and make this work as best we can. We know we've managed to get several successful methods of fooling the voltages, etc. And we were trying the pre-driver IGBT plus 48 volt system. That didn't change the behaviour of the zone where the current decreases. So I think we have to accept probably that we're not going to be able to defeat that, and it's probably just a function of a lower voltage. But we can use several hacks to increase current at in various ways. So this is a manual transmission MCM. It has the plus 40% current hack fitted. So we have the BCM interceptor here, and this is connected to the IMAC&C, which is underneath here. So the IMAC&C can control the flags for the regen and assist. And the IMAC&C now has a new function. We've taken the SCS connector, which was the way you could enable flashing out of DTC codes, and I'm using that actual output now to drive this new board here, and I'll explain that in a moment. So what else we have at the moment is we have the summing op amp, and we have a plus 48 volt supply here. So normally the car will operate with the plus 48 volt supply operating and the plus 48 volt summing op amp to add voltage to the actual pack voltage to give us a voltage which is in the normal operating range for the IMA. This one differs slightly in that if you look at the back here, we have a connector here. So this is where the actual pack is connected. So the full pack voltage, or the actual pack voltage, will come into the unit here, and then it goes back out of the unit again on the normal MCM HV connection, and that goes off to the BCM fooler and the BCM taps. So this doesn't actually have any other connection apart from it plugs into this. So I wanted to try and keep all the mods inside this one box. So this just connects to the actual battery, so that we get the battery voltage coming in here. So battery voltage comes in here. Then we have negative going to the negative output for the BCM fooler, etc., and then negative input into the MCM HV detection. Then the negative comes around over to here, and it forms the bottom part of a Zener diode network here, which gives us our 120 volts fixed voltage for the maximum power hack, which this relay switch is in. It also gives us a 120 volt equivalent voltage divider here, MCM, for the 5 volt V pin. So when this is activated, it basically switches out this board and switches in this board, which provides the 120 volt fixed equivalent voltages. So the positive side of the battery comes in here, goes into the negative of the DC to DC converter, and plus 48 volts is added on. It comes out the other side and goes off into this switching board here. And the only reason there's a relay on this particular board is this is to cut off the pack voltage from any of the resistor matrices, etc. So when the car is off, then there is no parasitic load on the pack, the lithium pack. So if you left it for like a year, I mean the drain would be absolutely minuscule anyway, but it just cuts that off, so there isn't a parasitic load when the car's off. So that's basically what we have. We have the plus 48 volt here. We have the plus 48 volt V pin equivalent summing op amp amplifier here, which adds on 48 volts. So the car normally operates in the 168 volt range, but when you engage maximum assist, and the IMAC&C slave here receives a full command power duty signal request from the OBD2 CNC and the joystick, it then engages this, and this then switches in the 120 volt fixed equivalent. So I've just tested this all on the bench, and it all seems to work. Now obviously there's quite a lot going on in here, but it's not as complicated as it seems, and I've said that before, and it could probably all be condensed down, all this, including the IMAC&C, could probably all be condensed down with suitable component selection into a board, probably not much bigger than that one there, or something that would certainly fit into that space. Obviously it looks quite complicated. It's a prototype, so I've taken voltages from various points. This is the 5 volt supply to all these boards, and IMAC&C wires, and these are the V pin wires here. So basically it looks like it should work. This one also has the FSC, the fail short circuit IGBT flag, disabled, so it can pull more power. And I'm hoping eventually to up the current for the current hack to 50%. Now I tried plus 60 and that didn't work, I'm going to go for plus 50 and just see if we can squeeze a few more amps out of it. But this is the sort of system that I'm going to be testing from now on. And I think this voltage fooling method is the safest method of doing it as well, because when contactors engage and disengage, the system will be receiving the right voltages at the right points, rather than actually having a permanent fixed voltage solution. This one actually follows the battery voltage as it goes up and down and just adds on 48 volts to whatever the actual battery voltage is. So there's quite a lot going on, but it's probably not as complicated as it actually seems. And I wanted to keep all the mods inside the MCM, apart from the one resistor you have to have inside the BCM for the current hack. So that's everything inside the MCM. So we'll test this later and see what happens.